Jai Hind everyone. Welcome to another class of data communication networks. In this class, we will discuss in this lecture introduction to various type of transmission media which are used for data communication. So the main contents of the lecture will be, we will discuss different type of transmission media along with explanation for its various categories, that is guided media and unguided media. So first of all, what is a transmission media? We all know that in the data communication, large amount of information or data is conveyed from one place to another place, from one equipment to another equipment, and the distance may be very large or may be very small between them. We know that basically for data communication or for any type of communication system, we require basically a transmitter, a receiver, and certain kind of medium or channel. Basically, communication engineering process is used here, where the large amount of information or data is conveyed via electrical or electronic means. That means we have to use some kind of transmitter, we have to use some kind of receiver, and for conveying information we have to use some kind of media or channel, or that is we have to use some kind of physical medium that will connect the transmitter with the receiver. So transmission media is required for connecting transmitter with the receiver so that large amount of data can be conveyed from one place to another place. So basically, transmission media and the physical layer. Basically, for implementation of the system, we have been using some kind of models, networking models. Popular examples of network models are maybe, for example, OSI model, that is Open System Interconnected or Interconnection model. Second popular model that is used as is TCP and IP model. So basically, in these networking models, we use the layered structure or layered architecture, in that we have different type of layers. For example, in the OSI model, we have 7 layers, and out of these 7 layers, the top layer is known as application layer, and last or bottom layer is known as the physical layer. So when explaining the communication or data communication using the network models, we use layered architecture. So in the layer we have a physical layer. So basically, this transmission media that is used for conveying information from transmitter side to receiver side or one place to another place is basically represented at the physical layer level. So this transmission media is basically at physical layer level. So here we have a sender, or we can say that this side is the transmitter side, and then we have a receiver side, or we can say that this is the destination. Okay, so the information is conveyed from this transmitter side or sender side to receiver side using at the physical layer level, and for sharing of information, it is necessary that the transmitter part must be connected with the receiver part by using some kind of transmission media. So the example of transmission media can be, for example, a cable or maybe air. How we can use the air as a transmission media? Basically, this medium, air or any other, we can say that this medium will be a wireless media. Okay. So basically, for connecting the transmitter or sender side with the receiver side, the two must be connected with the help of some kind of physical media, that is known as the transmission media. And in the networking models, this will be explained or will lie at the physical layer level. Moreover, basically we have here information is in the form of digital data, or we can say that digital or binary data. So data is nothing but it is large amount of information that is conveyed. So for example, if we have data maybe in the digital form, so that will have a large number of bits in the form of 0, 1, 1, 0, 1, 0, etc. Now to transfer this data, this needs to be converted into or represented in the form of signals. Okay, so the data is converted into the signal, and signal propagates through the transmission media, and at this point also the signal is converted back again into the data. Now this process of converting data into the signal, this is represented using some kind of encoding. For example, line coding can be used. Line coding techniques can be used for converting the data or message into the signal, so that signal can propagate from one side to another side through the transmission media. So basically, transmission media, by definition we can say that anything that can carry information from source to destination. So any physical media that is used for carrying the information or large amount of data from transmitter side to receiver side or sender side to destination side, we will say that that is as the transmission media. Popular examples of transmission media can be, for example, air for the case of wireless, twisted pair cable of wire, coaxial cable can also be used as a transmission media, optical fiber can be used as a transmission media, any conductor can be used as a transmission media. Further, we will see that the transmission media can be of two types, may be guided and unguided. Okay, so popular one is guided media. Let's say basically guided media provide a conduit from one device to another device that include a pair cable wire or coaxial cable and maybe optical fiber cable. Here we have specified a number of examples for the transmission media. Out of these three are the examples of guided transmission media, where the signal is properly guided through the conduit from the transmitter side to the receiver side. Basically, in the guided media, the signal is properly guided through the wired channel or media. The examples can be these. So here is the different classes of transmission media. As we have already discussed, the transmission media is the physical media that connects the transmitter side with the receiver side or source side with the destination side, or any medium that is used for transmission of message or data from one place to another place. So this can be categorized into two parts. One category is guided media. We can also say that the guided media is another name is wired media. Another category can be unguided, or we can say that this is wireless. Nowadays, wireless communication is very important and is become very popular. Although both types of media have some certain type of advantages as well as limitation, in the similar way the unguided media also has some kind of advantages as well as some kind of limitations. So the examples of guided or wired media transmission media can be twisted pair cable, coaxial cable and optical fiber cable. Another example of wireless transmission media can be free space. So the signal is guided through the free space, or we can say that through the air or through the atmosphere. Examples of this can be, for example, free space optical communication is the example of communication that is using the unguided or wireless media. Another popular example is mobile communication. Nowadays we are using. So mobile communication uses the wireless transmission media. So as we have discussed, we can define the guided media. So guided media is one in which we provide a dedicated conduit from one device to another device for carrying the information or signal from transmitter side to receiver side. As we have seen, these three are the popular examples: twisted pair wire, coaxial cable and optic cable. So these are some examples. So this is twisted pair cable. So twisted pair cable is the simplest and particularly used when we require when the data requirement size is very less, or we can say that the bandwidth required is very less, or when we have to transmit the data at a very low speed. So twisted pair wire, as we can see that here we have a pair of conducting wires which are covered with insulator material. Insulating material is there over the wire, and we can see that we have these two conducting wires are twisted with each other. So this is one example of transmission media. This twisted pair wire can be divided in two categories, or can be of two types: UTP and STP. UTP stands for unshielded twisted pair and STP stands for shielded twisted pair. In the diagram we can see that in the shielded twisted pair we have metallic shield over the insulating material. We have a pair of conductors that been covered by the insulating material, and we have a metal mesh or metal shield over the insulating material of the twisted pair wire. So here we have the shield, and here is no metallic shield is present. So that's why this is called as unshielded twisted pair, UTP. So if we compare difference, we have already seen in the diagram that in the shielded there is a metallic shield over the insulating pair of twisted wire, conducting wire. So basically unshielded has no shield, metallic shield, where the shielded twisted pair has a metal foil braided mesh covering the pair of insulated conductors. Now with the UTP, what type of connector that we are going to use in the practical? Basically, whenever we have to perform the data communication, so we have to use some kind of transmission media. So transmission media must be used with some kind of connectors, so that that connector can be connected with the communicating device. So the connector here, a popular connector is known as RJ45. So RJ45 connector is popularly used with the UTP wire. We know that popular RJ45 connector is basically used in the LAN communication, local area network. So LAN connector is also basically RJ45 is known as the LAN connector. These are the examples or diagram for the UTP connectors. UTP connectors can be the female version or the male version. So we have eight conducting lines, this connected with the wire. So whenever we have to connect, this male RJ45 connector gets fitted into the female. The popular application we have seen in the, let's say, in the desktop computers, as well as also we can see that in the laptops, where the RJ45 connector female and male are used. We can see the performance comparison of different type of or different size of UTP wires. Basically the UTP wire, unshielded twisted pair wire, is categorized depending upon the gauge size. We can see that there is different gauge size for the UTP wires. Basically this gauge size defines the or gives the measure of thickness of the wire. So here we have shown some examples. This is the gauge size and here we have the diameter or size of the wire. Here we can see that clearly with the increase in gauge size, of the UTP wire, the attenuation or losses in the wire get also, or in the transmission medium also gets increased. So for better performance we have to use with UTP wire of lower gauge size. Another example of wired transmission media can be coaxial cable, that we have seen popularly in the case of cable TV. So here we have a inner conductor, then we have some insulating layer over it, then we have the insulator is there, then we have a outer conductor shield or mesh, then we have another insulating layer, and then we finally have the outer plastic cover. This is also known as the outer cover for protection purpose. So this cable is known as the coaxial cable because here we have in the cylindrical structure there are a number of layers are there, but all have the common axis or same axis. That's why this is known as the coaxial cable. And whenever we have to make connections, so one connection will be made with this conducting wire and another connection will be made with this outer mesh or outer shield. So we can say that this will work as a maybe positive, or we can say this may be used as a negative, or maybe for the ground purpose. So the coaxial cable can also be available in various categories, maybe for example RJ11, RJ58, RJ59. This is the impedance values for these coaxial cables, and these are the some popular applications, that is RJ59 category coaxial cable can be used for the cable TV, and this RJ58 and RJ11 can be used in the case of Ethernet or LAN connections. As we have seen, for the case of the twisted pair wire, we use RJ45 connector. In the similar way, for the coaxial cable, For the coaxial cable, we use BNC connector. Okay, that is devices communicating and using the coaxial cable as a media needs to be connected through the BNC connectors. So here we have seen different positions or different types for the BNC connectors. So one may be the connector, another may be used as a terminator. Okay, so we can connect the coaxial cable with the help of these BNC connectors. Next popular medium is known as the optical fiber cable, OFC. In the case of wired media, nowadays the most popular media, transmission media that is being used in communication applications is, or in all modern communication applications is, optical fiber cable. Okay, so optical fiber is also guided media, and this is preferred because of certain advantages. Let's say, for example, bandwidth is very high with the case of optical fiber. We have security. The data transmission is very fast through the optical fiber because we use light as a medium, light as the information is conveyed in the form of light, so it is very fast. Losses inside the optical fiber are very less as compared to the any other media. And we know that optical fiber communication is basically based on the working principle known as the TIR, that is total internal reflection. Okay, basically we have, okay, so we have optical fiber where the information is conveyed through the fiber in the form of light, and principle used is total internal reflection. So with the optical fiber we can use different modes, like multi-mode optical fiber can be there and single mode can be there. And in the multi-mode there can be two options: multi-mode step index fiber can be used, or multi-mode graded index fiber can be used. Here we have seen different modes as discussed, and inside the fiber there is a phenomena that is known as the dispersion, that is broadening or spreading of light pulse inside the optical fiber cable occurs. So this is the one diagram for the optical fiber construction. These are the different type of optical fiber connectors. Basically for the optical fiber cables we have to use specialized connectors. These are known as the splices or optical fiber connectors. And optical fiber communication is highly wavelength dependent. So we can see that the losses inside the fiber as a function of wavelength have been explained in this diagram. So in this video lecture we have discussed the transmission media and mainly the wired communication transmission medias. So thank you all, and references are shown in this slide.